The Perseverance rover, which cost NASA $2.7 billion, luckily made a picture-perfect landing on the floor of Mars' Jezero crater, which scientists believe was filled to the brim with water 3.8 billion years ago. 2 kilometers away looms the rover's primary target, a fossilized river delta that is ideal for preserving signs of life. There will be no drilling at the landing site itself, but there will be flying. After the month-long commissioning phase is over, the team will find a nearby flat spot to use the helicopter on the rover's belly. The Perseverance is the first flying rover on another planet. The main mission is to search the planet for clues that could be used to create a timeline of events for Mars. Even after receiving only the first images back from the rover, Katie Stack Morgan stated, quote, "We have enough for the scientists to really sink their teeth into," end quote. Even the first grainy and blurry images returned to Earth left the team incredibly happy and excited for the future. After only 3 days, the rover has executed 5,000 commands and captured a panorama of its surroundings on Mars. After several days updating software, the team plans to wiggle the rover's wheels and conduct a short test drive. The rover will also extend its 5-jointed, 2-meter-long robotic arm, which carries the rover's coring drill and several more cameras, and put it through some calisthenics. A second robotic arm, designed to manipulate a cache of dust and rock samples inside the rover, will be run through its paces. As always guys, please remember to like, subscribe, and follow me on Instagram and TikTok for more videos just like these. Let's get straight into it. Stored in 43 ultra-clean tubes, the rover will take samples from Mars. This is part of a multi-billion-dollar, multinational effort to collect Martian rocks and return them for analysis on Earth. The team also planned 2 additional missions later this decade to retrieve more samples. Within its first 2 years, the rover is expected to fill nearly half the tubes on its journey of more than 10 kilometers or 6.2 miles to the crater's rim. The rest will be filled in an extended mission as the rover moves beyond the crater to ancient highlands thought to have once held geothermal springs. Perseverance's primary mission is to search for evidence of past life captured in the delta mudstones and other rocks likely to preserve organic molecules or even fossilized life. But interpreting this evidence will also require a better understanding of Mars' climatic past from clues that can be collected right away by the rover. Some scientists believe the rocks from where the Perseverance landed are from an ancient lava flow that erupted long after the lake disappeared, arguing that they look the way Hawaiian flows might if bombarded by meteorites and whipped by winds for several billion years. But when Perseverance's predecessor, the Curiosity rover, explored similar rocks in the Gale crater and its ancient lake, most of what scientists had thought were lava fields turned out to be sedimentary rocks. Sedimentary rocks are ground-up volcanic bits transported by water and deposited in layers, presumably in the vanished lake. The early pictures from Perseverance are difficult to interpret. The pictures indicate rocks riddled with holes, which could be a type of volcanic rock, or they could be sedimentary rocks. Fortunately, Perseverance's scientific instruments are designed to pin down the rock's origin. Cameras on the mast could spy distinctive angular striped layers called crossbedding that only form when deposited as sediments. A camera mounted on the end of the rover's robotic arm from microscopic views could capture the grain of minerals. Sedimentary rocks, for example, are typically rounded by their watery travels. 2 other instruments on the arm will fire X-rays and UV lights at rock samples, provoking reactions that could reveal chemical fingerprints of volcanic or sedimentary rocks. It's a crucial distinction. If the rocks are volcanic, either lava deposits or, more likely, ash from a distant eruption, they'll contain trace radioactive elements that decay at a certain rate, so when samples are returned to Earth, lab scientists could date the eruption and put a bound on the age of the lake. Knowing the date is crucial in the highly uncertain overall Martian timeline, currently dated by counting the number of craters on a given terrain. This is because older surfaces are packed with more craters. Sampling a volcanic rock could prove to be critical in figuring out Mars's timeline. The rover's initial path is likely to cross another intriguing target just 250 meters away on the crater floor: volcanic ash. If this layer is volcanic ash from an eruption that preceded the Jezero Lake, radioactive dates from it and the potential volcanic layer deposited on the lakebed should place the lake's existence in time. Moreover, isotopes of oxygen in the carbonates could reveal the temperature of the water that formed the mineral. This is because warm water would suggest Mars was once warm and wet for a million years at a time, whereas water near freezing would argue for scattered bursts of warmth. The carbonate might even contain gas bubbles which could have samples of the ancient Martian atmosphere, which could allow scientists to see whether it held methane or other greenhouse gases that could have warmed early Mars. With flying rovers on Mars and more information on the planet to come, maybe in a few decades we'll be able to go there one day.